Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello students, subscribers, viewers, and future engineers. Here is another set of problems in Engineers in Progress, which are very important for your mathematical development. So you begin with simple problems like this, ratio and proportion. So problem 14, find the coordinates of the point on the y-axis which divides the line segment from 0, negative 4, which is here, to 0, 20 internally in the ratio 5 as to 7. So this point D, point of division D, from this lower point to D to the upper point, the ratio is 5 over 7. So I denote D as 0, y, and for it to be positive, it should be upper y minus lower y. So y minus negative 4 is y1 rather, minus negative 4 is y1 over 4. That's the length. While from D to this upper point, to make it positive, it should be upper y 20 minus y1. And 20 minus negative 4 is 24, the total length. So therefore, the ratio of this length, y1 plus 4 as to 20 minus y1, is 5 is to 7. So cross multiply 7y1 plus 28 equals 100 minus 5y1. 12y1 equals 100 minus 28, 72. So y1 equals 6. So therefore, the point of division is at point D is at 0, 6. So allow me to have the solution ready-made so that I can discuss so many problems in just a short number of minutes for the video, and to shorten the file size also. Now, if you want to anticipate the solutions to this problem, you can by pausing the video. Do not look at the solutions. You just look at the answers later after you solve the problem. So problem 15, find the mean proportional between A 9 and 9, B 6 and 216, C 2a cube and 4a, D negative 4 and 64, and E y square and x to the negative 4, F negative 2 and negative 8, G is 1/4 and G 1/4 and 1 over 64. So this is the guide. A as to x equals x as to b. X is the mean proportional between A and B is the third proportional to A and x. So that's the definition. Therefore, A is to x, A over x equals x is to b. So cross multiply x squared equals ab. Therefore, x is plus minus square root of ab. So this is our guide formula so that we can solve and analyze these problems shortly and easily. So for part A, x is plus minus square root of 9 times 9. So it is plus minus 9. For part B, x is plus minus square root of 6 and 216. So that would be plus minus 36. For part C, x is square root of plus minus square root of 2a cubed times 4a. So that would be 8a to the fourth, or 4a to the fourth times 2. We can only extract the roots of 4a to the fourth, square root of 4a to the fourth, which is, so we have plus minus 2a squared square root of 2. Part D, x is plus minus square root of negative 4 times 64, since Negative 4 times 64 is negative, and we cannot extract the square root. We have an imaginary root, so therefore plus minus 2i times 8, so that's plus minus 16i. Part E, mean proportional is plus minus square root of y squared times x to the negative 4. So that would be plus minus square root of y squared over x to the fourth, which is plus minus y over x squared. Part F, x is plus minus square root of negative 2 times negative 16, which is plus minus square root of positive 16. Therefore, it is plus minus 4. Then part G, x, the mean proportional between 1/4 and 1/64 is plus minus square root of 1/4 times 1 over 6 times 64, so plus minus 16, so it is plus minus 4. So we have 1/4 and 64, so plus minus 4. Problem 16, find the fourth proportional to each set of numbers. So 2, 4, negative 6, B, 5, negative 3, 6, and C, 2A, A square, B square. So this is the guide. A as to B equals C as to X. X is called the fourth proportional to A, B, and C. So therefore, 2 over 4 equals negative 6 over X. So X is negative 24 over 2. So that's negative 12. Part B, X 5 over negative 3 equals 6 over X. So X is negative 3 times 6, negative 18 over 5. And that's negative 3.6 in decimal form. Then part C, 2 over A equals A square B square over X. So X is A cube B square over 2. So that's it for problem 16. Then for problem 17, find the third proportional to each pair of numbers. So we have A, B, C, D. So this is the guide again, same as here. So A as to B equals B as to X. B is the mean proportional between A and X, while X is the third proportional to A and B. So A over B, A is to B equals B as to X. So the formula for X, our guide is B squared over A. So for part A, the third proportional to 5 and 8 is 8 squared over 5. So it is 64 over 5. For part B, it is 3/5 square over 2 and 1/2, which is 5 halves. So 3/5 square over 5 halves, that's 2 times reciprocal. 2 times 5 cube, because we have 5 square. Then times 9, that's 18 over 125. For part C, X is 3 and 1/3. 3 and 1/3 is 10 thirds. So 10 thirds square over negative 3. So that would be 10 square over negative 3 times 3 square, negative 27. So negative 100 over 27. Then for part D, X, or the third proportional between A, third proportional to AM and BM square, is quantity BM square square over AM. So that would be B square M cube over A. M to the fourth over M is M cube. Then problem 17. For any proportion A as to B equals C as to D, prove the following properties, provided that no denominator which occurs is 0, because division by 0 is undefined. So the product of the means equals the product of the extremes. So let's show that AD equals BC. The means may be interchanged without destroying the proportion, or A as to C equals B as to D. And said to be obtained by alternation. Then the equal ratios may be inverted, or B is to A equals D is to C, said to be obtained by inversion. Then quantity A plus B as to B equals quantity A plus D is to D, said to be obtained by composition. Then quantity A minus B is to B equals quantity C minus D is to D, said to be obtained by division. So for part A, remember this is the ratio and proportion. A over B equals C as to D. So if we cross multiply, we have AD equals BC, which is the statement product of the means BC is equal to the product of the extremes AD. Then B, the means may be interchanged. So A is to B equals C as to D. We can write it in this equation. A over B equals C as to D, multiplying everything by B over C. So we'll have AB or A as to C, A over C, because we can cancel B, equals B over D. Then we cross multiply. We write this in this statement. So A as to C equals B is to D. So that's the equation. This one. A is to C equals B is to D. Then the equal ratios may be inverted. B is to D equals D is to C. So this is the original equation. Then by interchanging position C and D, we can do that just like cross multiplication. So A over C, or from the result in part B here, A over C equals B is to D, then we have to apply algebra here. Interchange position between A and D. D is to C equals B is to A. So finally, B is to A equals D is to C. Then in part D, we have to show that A plus B over B equals C plus D over D, and we add 1 to both sides of the equation. So A over B plus 1 equals C over D plus 1. By algebra, we simplify this into A plus 1 times B, so A plus B all over B. And here the LCD is D, so C over C plus D times 1, or C plus D over D. So that's the statement, which is this. Then finally, instead of adding 1 to both sides, we subtract 1 to both sides. So let us show that this is the ratio by division. So A over B minus 1 equals C over D minus 1 from the original statement here. So we simplify this into A minus B over B equals C minus D over D. So that's the statement. So that's it for this video. I hope that you were able to follow the explanations, and you also, for those who attempted to solve these problems, you were also to arrive at the same answers.